Hey guys, BBI here. I want to stop and say thanks for tuning in and checking out whatever the video is about that's about ready to come up next. If you could take a minute and hit subscribe, I'd greatly appreciate it. And if you enjoy what you've seen here, make sure to hit the like button. We'd greatly appreciate your support. Anyhow, guys, all that aside, let's get on with the show. Let's see, what is today's pain? This is today's pain. I don't know what this is. This is an Xforce 412 HD bass amplifier. Old school gray label Carl built. I don't know what we got going on the inside. I don't know. I don't know where this came from. I don't know what deal this came out of. I've never even heard of this before. It's heavy, so it tells me it's got a transformer in it, which is good. It's got sideband and a preamp in it. Let's take a look for underneath the hood, yo. Ah, 4-pill Toshiba. Cool. But what do we have here? A varnish and coated transformer. That's different. With the old school Carl built bias in it. This is legit non-red dot 2879. I bet this sucker just runs. Let's find out. Let's pull this out of here for a minute. Pitch that. Well, let's plug it in and see what happens here. We'll go down here and we'll, I got a 30 amp 110 outlet right down here that I use specifically for these old girls. If these weren't such a pain in the ass to ship and not get damaged, and the transformers are more readily available, and I don't know, I just I'm not gonna lie, these always have worked really well. The Fat Boy Xforce style boxes that are like this. Transformer, big heat sink, runs from here to here, where towards the end they would have run from here to here, or in some situations they'd run from here to here. I'm not kidding you, but that wasn't Carl, that was you know who. Okay, let's see what kind of windings we got on this one. Hands working. So we got a noise ripple. Nothing. Just some static on the lines. Cool. See if we can talk through it. Hello, 1-1. A little bit high, but we can fix that. So Let me slow down. I'm leaving you all behind. I'm pretending like you're inside my mind and you're not. So when we look at this on the DC setting, what we're looking for is how many volts are on the power supply. Then I flip it back over to AC setting so I can see how much voltage the bridge rectifiers is leaking, which is, you know, the amp's off, but which is almost next to nothing. 0.001 floating of a volt of AC ripple, making it past the filter cap, which is cool. It's a 110 volt fan. It depends on how you operate this box, if that fan's gonna be enough for you. If you want to sit there and hold the key down, I had one friend of mine, good old barbecue man. He had one of these, and we ended up having to put a blower in here to put enough air through the cabinet to get enough airflow across the heatsink to get the transistors to stay together for him. But he was really long-winded, and very long-winded man, and that's okay. We ended up putting stud diodes in it, and we doubled down on the transformer and put a ton of wind through that box, and finally got it to where it would run for him. So the first thing I did is I keyed it up, and I made sure that I could get the RF to go in the amp from this connector through all this and then back out with little to no resistance. And we've got like a half a watt worth of reflect, which isn't horrible, but it's not dream team stellar. And I lied to you. The heatsink on this goes from here to here. Wow. You can literally see. This is the first one of these that I've ever done that I don't have to go and block this off back here. Normally the heatsink would stop about here on the board, right past that screw. So we'd have a big open window over here in the corner. Well, all our cooling air pressure would go in, run right out that hole and come out the box. It wouldn't go out, tumble around inside a cabinet, and then get forced across the heat sinks and cool anything. Man, it's got a supersized heat sink in it. Let's see how well it runs. So let's come over here. So as always, 1,000 in peak, 1,000 in average, 5 watt slug in reverse. Let's turn the bird meter so it's reading forward. We're going to put out 1 watt. Bench is on 12 volts over here, 12 volts, which means it's going to make about 18 watts of power here. Hello, dead on the money. So let's see how well this thing runs on 18 watts worth of shmoo. Hello. Oh yeah, it runs pretty good. Hello, audio. Hello, audio. Making about 400 watts peak with about 20 watts worth of drive. Not bad. Hello, 1111. Input needs a little bit of help. That's a 5 watt slug in reverse between the 2950 and this Xforce 4-pill. Hello, 1111. About a watt worth of reflect. We'll get that down. We'll polish that out. Hello, audio. 380 watts. Okay. Let's switch radios now. Just for curiosity's sake. Let's grab up this. Now we're going to grab the D-Rail Bench Striker 955. And we're on 12 volts. 1 1, hello, 1 2, 1 2, 1 2. Hello, 1 2. About a quarter watt worth of pass-through reflect. Let's come back down over here. Hello. It's amazing. This radio is amazing. On 12 volts, it makes the same amount of power that a normal 955 on 14 or 15 volts makes. It's a crazy radio. Okay, let's go ahead. Making about 80 watts peak on 12 volts is my point. You see that? Hello, 1, 2. Hello, 1, 2. Okay, now you're only seeing 200 bird and 1,000 watt peak. So let me reach up here and I'll turn the knob on the derail radio. Hello, about 400 average, which is perfect. It's a 1200, it's a Xforce 1200, or Xforce 400, 12D. Hello. See the voltage on the power supply? Let's reach up here, we'll dial down the bird watts. Hello. Pulled 200 bird out of it. We're still making 1,000 peak, but instead of getting pulled all the way down to 12 volts, now we're falling down to 14.5, which is perfect. Absolutely perfect. All right. Sideband delay is working perfectly. Okay. That's freaking neat. So what's it do if I run the radio up a little bit? So let's go ahead and we'll bring the voltage up on the bench. There's 14. You can see 14 here. And also down here, we're seeing 14 volts. Power supply is going to push to 15.1. There we're at 15 on the radio. Hello. Off the chart. Hello. Okay. Let's go ahead and we'll turn that off for a minute. Now we're doing 80 watts peak before. Now with the derail striker in play. Hello. About 120, 130 watts at 15 volts. And 120, 130 watts into this little guy. Hello. Burying it in a corner. It's good, we'll flip that up to 2x. So now, what we're looking at is that big hash mark directly between the 20 and the 30. Focus. That big hash mark directly between the 20 and the 30 is 1,000. So 12, 14, 16, 18, 2,000. Okay. I'm betting 13. Say 1350. But oh, wow, 1,400 watts. Wow, that's a good little box. But oh, 1, 2, 1, 2, 1, 2. And the input tune on this thing is shockingly not too bad. Let's look at the SWR bridge on the front of the radio. That's the lowest graph, of course. Hello, 1, 2, 1, 2, 1, 2. Okay. Let's go up here and look at the 5 watt slug between the 955 and, of course, the 4 pill. Hello, 1, 1, 1, 1, 1, 1. Hello, 1, 1, 1, 1, 1, 1, 1, 1, 1. It's not earth-shattering. Like, it's definitely not going to hurt the equipment. This little guy gets with it. It gets with it. Let's see. The only thing I got left that I want to make sure works is the preamp. We got to go back over to the bench 2950 to check that, since I got the speakers muted on the striker. Preamp is most definitely working. Okay, well, I want to go in and replace these, and I'm pretty much going to leave this alone. There's no reason to sit here and mess with it if it's not working. You know, if it's working great, don't mess with it, right? I just want to upgrade these a little bit, and then I want to take this wire and move it from out here on the edge. We're going to put it in the middle over here. And that's to guarantee that both sides of the amp, this 2-pill section and this 2-pill section, get the same amount of current. Will we see any performance increase? Maybe 25 or 30 watts. Okay, so we're back on the bench 2950. And the only thing we have done so far is put the power wire upgrades in here and move the power wire from being out here on the edge to in the middle, so everything gets equal amount of current, and we're upgrading the current's ability to get to the transistor. This style of amplifier is where this design was born from. Okay, everybody goes, it don't make no difference. Okay, let's prove this. We haven't changed the input capacitance, output tuning is exactly the same, everything is the same. We're on 12 volts over here, like what we were on the first test. 1, 2, 1, 2. Let's go back over here and let's look at our watt meter. We're on the 1000 watt scale. Hello, 1, 2. Same amount of same. Okay, 18, 20 watts. Now, if we remember correctly, we were making about 400 watts PEP. So that means we're looking at this meter and we're seeing it go just to about the 40. Okay, so making about 380 to 400 watts. Same drive, same everything. So we picked up 100 more watts on the low end. 1, 2, 1, 2, 1, 2. 1, 2, 1, 2, 1, 2. Okay. So we're seeing 100 more watts with the same amount of drive. And all we did was change the power management on the inside of the box. So let's go ahead and let's come off the 2950 and let's start making it make bigger numbers. Now we're going to put the Striker 490 into this thing. Or not 490, pardon me, Striker 955. 80 watts. Hello, 1, 2, 1, 2. Let's look up here at the front of the radio. 12.5. Hello, or pardon me, 12.8. Hello, 1, 2. Now, so we're running at 12.5, just where we were at before. Now, if we remember correctly, we were barely getting 1,000 watts. It was like 980 to almost 1,000 on the peak scale with this radio. Let's go ahead and let's turn the power or the amp back on. Hello, on the stop peg. Hello, on the stop peg. Did I make the amplifier do any more power? No. We're going to top out, because of the voltage and the amount of amperage that we have available and the amount of drive, I predict that we'll top out at the same amount of power. But what we did do by changing and coming off of this is our power distribution network to this, and instead of having the wire out here, which allows this 2-pill to get the most current and then this to get whatever's left over, by splitting it, by coming to the middle, now we're allowing everything to operate more efficiently. We've picked up the efficiency of the circuit that surrounds the transistor. The transistor is going to produce the same amount of current no matter what. The only thing that's going to dictate to the transistor how much power it can put out, actually achieve, like come out of the component, get coupled and come out, is going to be the efficiency of the circuit and, well, the efficiency of the circuit that's around it. We cannot change how the device operates, but we can change how the circuit is around the device. Okay? Another way to put it is, we cannot change the efficiency of the device, but we can change the efficiency of the circuit that surrounds the device. And the more efficient that we can make the circuit that surrounds the device, therefore the more power we're going to be able to couple from the device to the circuitry. Okay? Sounds really complicated. It's simple. The better we make this work, the better the rest of this works around the transistor. So therefore the transistor gives us the idea, or presents to us, that it's working better. Where the transistor is still working the same. There might have been a slight imbalance, but there's going to be a difference in voltage between here and here if this wire is over here. Now please note, we're talking about in full chooch operation, 50 amps, 50 amps. So 50 amp and 50 amp. So we're pulling 50 amps through this length of wire. 50 amps through this length of wire versus 50 amps. Now this is a little bit overkill. Is it necessary to have this big a wire? No. But this is the design platform that I landed on nearly a decade ago when I found out just simply by moving a couple of the wires around and changing our power distribution, we can make the box run more efficiently. Now that efficiency presents itself in a couple different ways. One, more shmoo on the watt meter. And then two, it shows up as less heat inside the box. Because the transistor is going to make the same amount of power no matter what. If the circuit around the transistor isn't in tune to the transistor's input or output impedance or input impedance, the rest of that extra power that's not able to come out of the device now gets turned into heat and goes to the heatsink. The more efficiently we can make that transistor work, as it's power coming out of the transistor and the circuit that is feeding the transistor, the less amount of heat the transistor is going to generate. By doing this, we've also decreased slightly by like maybe, I'd say maybe 6-7 amps total, decrease the amount of current that is being applied to the power supply. The more efficient we can make the power distribution going to the device, the less amount of current the device is going to pull to achieve the same amount of function of operation. Okay, so on 12 volts, hello, 1111, 80 watts of drive, 12 volts, hello, on the stop peg. All right, so it's at 12.7 up here. Let me slide you guys over here to the side for just a second. And let's reach down here. Let's turn on a bench supply. And let's bring all the super caps up to a charge. So now we're up to 14 volts. 14.9, 15 volts here. 14.9 here on this display down here. So we're seeing 200 bird, 1200 watts. Still 200 bird, but let's turn on our peak kit. Now we're on 2X. Once again, this hash mark right here, 1000 watts, 12, 14, 16. Okay, so we were making about 1400 watts of power before. Let's zoom on in here. Let's make this really clear about what's taking place. Still making the same 1400 watts worth of power, just not as lazily. So we changed the amount of watts that the amplifier can produce. We've increased its sensitivity so it does more with less. But we've reached the top end, or otherwise what they refer to as saturation of the component. So now we're going to play with all the other little settings, like this here. Hello, 1 2 1 2. Whoa, look at that. Hello, 1 2 1 2 1 2. Seems pretty low compared to what it was. And all we did was change the power supply. I haven't messed with this at all. We might add a little bit of capacitance over here, just a little bit, but the main thing that I want to do is I want to add 20 puff worth of capacitance from this pin on the relay to make it so that the RF can come in this post and go out that post as efficiently as possible. So let's start here. So what we did is we added 5 puff worth of capacitance here, so it wasn't that far out of tune, and then we added 20 puff worth of capacitance here. So now let's go up here and we're going to look at, with the amp off, let's do this in a sequence of events that makes sense. Amplifier off. Hello, 1 2 1 2 1 2. That was at 3 bars before. Hello, 1 2. Okay. That's cool. Now, let's turn the amp on. Hello. 1, 2. That's our input tune. And that's specifically this cap. So that 5 puff does make a small measurable difference. Is it night and day like would it cause the amplifier to quit working? No. We're just making sure that this thing's got the best chance for success wherever it ends up going. Okay, once again we're on 2X. And let's see, we're seeing 14 and some change. Hello. Hello. 1, 1, 1, 1. Perfect. Absolutely perfect. Well, gentlemen, once again, this is one of the Mr. Black collections. It really is. The only thing I got left I want to do is I want to blow it out with an air compressor real quick, make sure there's no little dust, dirt, or anything in here. We're going to spritz this down with clear to keep it from corroding any further, and then we're going to put the lid on it. As we're sitting here waiting for the clear to dry, I wanted to point out something really quick. This amp is not like the rest that I have dealt with. This is one of the few that Carl and the boys put this in here. This here is a thermal switch, or couple. It's a heat activated breaker, basically. If it gets too hot, it's going to break connection. And guess what? The amplifier is going to shut off. The fan's going to keep running. You're going to sit there and click, 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 click. You're going to key it and nothing's going to happen until the amplifier cools down. This switch is there to protect you. Now, I can almost guarantee dollar to donut, whoever ends up buying this amp within 3 months of them owning it, I'm going to get a phone call and they're going to say to me, man, this thing just keeps cutting out. I got to turn it off and let it sit. That's not what you want to do, by the way. I got to turn it off. I'll let it sit for 30 minutes and then it'll run for another 30 minutes and then it just overheats. And I've only had it keyed down like 4 or 5, I only key it down for like a minute or 2 at a time. I've seen this before. Believe me when I tell you, I have seen this struggle before. Look, when the amp does this, taking into account the heatsink goes from here to back to here at the edge of the cabinet, if this heatsink is so hot back here that it's causing this switch, which is set to just like break out at like 150, 160 degrees, it is really time for you to stop talking. Guys interpret this as there's something wrong with the box versus saying, oh wow, I got it too hot. Either you got it jammed up too close to a wall and the heat's recirculating, as in it's coming out of the heat sink vent and getting sucked right back in the amplifier. So you don't have enough cool air moving around, or you got it up in the cabinet. They don't want to look at any of that. All they know is that their amp stops working, and to them it's an intermediate problem. At $225 a piece, there is $1,000 worth of Toshiba non-red dot transistors in this amp. Yes, this is one of the ones that we could easily pluck the Toshibas out of it and put HGs directly in its spot, and then you would have $25 a piece or $30 a piece, whatever they sell for, HG transistors in there that if you blow them up, no one really cares. Oh well, we effed off some HGs, life goes on. $225 a piece Toshibas. And they're going to get upset when they drive the poopy shorts off of this thing. And when it gets too hot, it's got a built-in device that says, time for you to stop, quit hurting me. I have seen it over and over and over again. So, whoever ends up buying this amplifier, be aware, be mentally understanding of the fact, this isn't an opinion, of the fact that it's got thermal protection built into the amplifier. And if this gets too hot, you're not going to be able to key it up until the amplifier cools off. your immediate knee-jerk reaction is going to be to turn the switch off. Do not do that. Leave the fan running. That way it can move cool air through the cabinet and strip the heat out of the cabinet so that this thing wants to close again. And you have to ask yourself, if I am running this thing so hard, because you're probably not mentally aware of it, but you're running the amp so hard that it's getting so hot that this thing is tripping on you, you need to readjust how you're operating this piece of equipment. It's just food for thought. No one's telling you how to run your station, but this is a pretty good indicator, a benchmark in operation, that if this device comes into operation, you need to either back the drive down, shorten up your key time, or you need to give this more air circulation back here so it can get more cool, fresh air in and let the heat come out over here. Okay, I'm down off my soapbox. Okay, just I want to make that very clear, that's all. So, once again, I cannot stress this enough. I'm not working for myself. I am working for the family on these little adventures. That's a pretty good straight working box. I mean, it's straightforward what we got going on here. There's $1,000 worth of parts inside this amp. Okay. And, you know, as I'm putting it back together, I have stuff like this happen. These screws are not the best that money can buy. They're not, they just break. So I went ahead and I replaced all the screws with stainless steel, higher quality screws. It's the little stuff like that that makes a big difference in the overall chain of events here, right? Little stuff like if this thing had HGs in it, it would probably be worth about $600. Because it's got the Toshibas in it, it's $1,000 worth of transistors. And so then the heat sink, the power supply, the cabinet, the power wire, everything that's in here is maybe worth $300-400 at the most, right? Short from the transistors. So that puts us in the $1,200 ballpark range for this box. Period. $1,200 to $1,300 for this box. We're going to go with the $1,200 price range. It has been astonishing to me as I go through this guy's equipment, my friend. He had the best of the best of the best that money could buy. I mean, he spent his money wisely, and I mean that when it's down to his truck, down to his guns, down to his radios, down to... Man, I got a whole mess of D-Row radios I've got to yet sell, but don't and please, guys, do me a favor, don't call me and say, I'll buy it right now sight unseen. That's not how this works. I've got to put a video up. Everything's got to be done with transparency. I can't... It would be easier for me to sell stuff like that. But you got to remember, I'm on the other side of the United States where this guy was at. So the family has to see me go through the process of looking at it, certifying it, putting it up for sale. I cannot just simply go, oh, okay, I'll take your money and then send them. There's no check and balance system in that way. So the radios will come up in their own time. I've got 3 guys that are pushing on me pretty hard right now to get his single 800 box that he had. That's going to come up here pretty quick. I got a guy that's really wanting his 24 pill. That's coming up here really quick. I got to go through this one step at a time. So for today's venue, this has got to go. I don't care where it goes, it just can't stay here. So $1,200 plus the ride. First one to call me or text me gets it. Okay, I gotta go. You guys have a good afternoon and enjoy the rest of your weekend. We'll see you. Click, click, click.